Hey, just thought I'd share what I've been doing for the past hour and 15 minutes. I used Gemini to make this app, and, yeah, this is what it does. These are binary strings. And, so I was interested in the question of if you interpret this as a linear threshold function, kind of, like a neural net neuron, except it's binary. The question I was interested in was that using any number of neurons, can you separate e.g., well, like in particular, can you yeah, can you like separate these 2 points? Meaning like in the layer, you would avoid putting a hyperplane between these 2 points, and like the hyperplanes always show up as horizontal lines. And so there's like an observation, which is that like if you're arranged, yeah, I mean that animation is amazing. That's all Gemini. But anyway, there's a observation, which is that right, if you're like in this arrangement, so like your parameter vector is like, distance 3 from both of these points, you can put a hyperplane like here to separate these 2 points from everything else, and then you can like put a hyperplane here to separate the 2 points from everything else. And so then it just becomes a question of like, can you separate, you have like this middle layer, which like as you increase n, I mean like n right now is 6, but as you increase n, the middle layer grows as n choose n over 2, which is like on the order of 2 power n or something. Stirling's approximation, people. So anyway, so you're gonna have a lot of these points in the middle, and yeah, we're like, okay, so can you separate like this all reds from like, if I just go through and select all the 2s, like all of these points are distance 2 from this guy. And then we're like, yeah, so what we need is we need to put a hyperplane between this group of points and the red, and the all reds guy, without also separating the all reds and the all blues. So if you kind of play with the thingy and the parameters, yeah, I'm not sure I've entirely thought about this all the way, but it's like the yellow, like the selected circles, they they either stick with the red guy, or yes, true, I haven't checked all 2 power 64 possible parameter arrangements, but anyway, it seems, yeah, so maybe this isn't like, this is more just kind of like empirical evidence of the behavior. There probably is a proof here, but it's like, yeah, empirically, the selected circles, yeah, like either stay in between the red and the blue. Because I mean, like if you're in this configuration and you don't want to separate all red and all blue, you have to, like the hyperplane either has to be here or it has to be here. Like you have 2 kind of choices, and none of those options allow you to separate the yellows from the red, not including this guy. Yeah, so I was trying to, like, maybe I'm Right. I mean, if you just do random stuff, it's like there's always a yellow that sticks with red. There's always some yellows that stick with red, which means you can't separate them. And oh, here's a configure it. Yeah. So okay, so you could actually, you can make the separation like in this configuration, like in particular. So if you put a yellow guy at the top as the parameter vector, you can always right. Let's see. Okay, so like, what if we put, say, this guy at the top? Yeah. Okay, let's try to make that guy go to the top. That was a bad click. Good click. Bad click. Good click. Right. So I mean, you can individually put them at the top and put a hyperplane separating each yellow guy individually from the red and the blue. Yeah, so you can, okay, so the new conjecture, I was gonna say it's impossible, but I think it is possible, because you can always separate a single point from everything else. So the new conjecture is that, you know, like, you need exponential number of these units, because, like, in general, there's going to be, like, an exponential number of, these guys. And these are just the distance. Oh man, I was trying to, yeah, these are just like the distance to, okay, yeah, let me go back to the original thingy real fast, because I also wanted to look at red. So if we put red there, okay, these are like distance 2s. So if we do distance 4s from red, meaning you have 2 reds. Right. Right, I mean, that's just symmetrical. So, I mean, like, these guys... Right. Yeah, so anyway, so, like, yeah, so, yeah, so it seems like the only way to perform that separation is, you need, like, exponential number of units. Cool.